Hi, everybody. This is a second part of the video for the Chemistry 10 practice midterm sheet. My computer died, so it got split into two videos. So there's already a video. You see number one. And now I'm just going to restart on the bottom part here. Okay. So part of the midterm is being able to make molecules based on ions. And you know what? Before we get started, I'm going to put in all the names, because one of the things you have to be able to do is actually name the molecules. And these boxes are too small for me to do this, so we're just going to write it here. So sodium, when it's an ion, is still sodium. Hold on, I'm looking for my pink sheet. This. If you don't believe me, look at, there it is, sodium. It doesn't change. And if we look up Fe+3, it's called iron 3. So you got to be careful with iron. Any of these ones where you've got two bits or two different ions, their name is always going to have the element and then a number. So this is going to be iron 3. And it's always Roman numerals. I think it's so you don't get it confused with all the other numbers that are going around. So this is lead 4. And if it's been a while since you've done Roman numerals, that's how you write 4. This is going to be barium 2. And this is manganese 7. Okay, that's how you do 7, because it's 5 and 2 more. And lead is 4, because this is 1 less than 5. There, things weren't square in my, careful on this one. Manganese. Manganese is there. Magnesium is up there. Two different things. Okay, magnesium only forms a +2 ion. Manganese, it's a crazy element. They show the 2 and 4 in here, but it also has a +5 and a +7 ion, and there might be more. I can't remember, but it forms lots of ions. And it's because it's in this transition middle area where the electrons are so far away from the center part where the protons are that sometimes it'll lose 1, it'll use, in this case, it'll lose 2, or it can lose 4, or it can definitely lose 7. All right, so a little off topic, let's get back to work. Oh, now we need to do these ones down this side. So if you remember, the positive ones, you just name the element, and sometimes you need to put a number behind it. When you have the negative part of the ion, that's where your names are going to change for sure. So when we look on this chart, no matter how hard we look, we're not going to find chlorine, but we will find chloride. If you're having a really bad day and you can't find stuff, I guess number one, whoops, goes this way. There's chloride. There's a Cl-. You can look on the back, or you could look on your periodic table, look up chlorine, find out it's number 17, figure out where it is in the periodic table, and ta-da, it's there. Except I was talking about chlorine, my bad. So chlorine, when it becomes an ion, becomes chloride. As in sodium chloride, which you know is, come on, say it. Table salt, sodium chloride. O-2 becomes oxide. Perhaps you've heard of carbon dioxide, huh? And nitrogen becomes nitride. Not really as common as the other two. Okay, so that's number 1. Now, as I'm going through this, I'm going to use our handy dandy little chippies, our paper cutouts, just as a support to how to cross charges. So in your little box, it's like a multiplication table. Oh, and you should remember, sorry, the positive part always goes first. So I'm going to put Na plus Cl minus. All I'm doing is just putting those in the box so I know what I'm working with. So if I go to do this one, Fe plus 3 Cl minus. Now, you know what? I'm going to do the whole row. Pb plus 4 Cl minus. So brought those down, chlorines all around. Now, when I cross my charges, number 1 is if the numbers match, all you do is bring them down together. So this becomes NaCl, which you've probably already seen. And for dramatic effect, there you go. It takes 1 sodium, 1 chlorine. Done. But that rule, everybody gets this one. It's pretty straightforward. Also applies when you have a plus 2. Whoops. And a minus 2. So when we get to one where it's like this, even though it's, when you want to cross the charges, you want to bring the 2's down. No, you are not allowed to. It just takes 1 of each. Okay, so by the same token, it's going to find a -3. Boom, there we go. So my world, if it's matchy-matchy, that phrase all the time, then you don't need numbers. You just bring the elements straight down and we're done. Okay, boom. Now Fe plus 3 in chlorine, the 3 goes there. It goes there. Now, the next rule, and these are all in your booklet, by the way, is this, I didn't write it, but it is a -1. And in chemistry, you don't write the ones as subscripts. You don't write them at the bottom. It's not even like math where, if I write X, write X to the 1, whatever, it really doesn't matter. No, in chemistry, it's wrong if you put the 1 there. And then the 3 goes here. FeCl3. So, and if we wanted to name it, we'd say iron 3 chloride. I forgot, this one would be sodium chloride. There's just not enough room for me to squish that in there. Okay. Notice when the numbers come down, the signs disappear. Because this stuff down, okay, it's only this one, is actually counting. It's not, it doesn't have anything to do with ions anymore. It has to do with counting. Now, I'm trying to find some scrap paper that I've written on. Why does this work? Well, if a compound has to be electrically neutral. So if we have 1 Fe, that's times plus 3, that's going to give me plus 3 for a total positive charge. Now my chlorines, I have 3 of them times -1 each. That gives me -3. And that gives me 0, which is what I'm looking for. Sorry, I'm working at home right now, and my dog, hey, go lay down. Jelly Bean is being very inquisitive and being a bug today. Hold on. Rare Bean, come here, come here. No, come over here. Come here, come here. Come here. Turn around, turn around. Okay, there, Jelly Bean. Oh, now she wants to be petted. This is my darling Jelly Bean. And this is why sometimes I don't get all my work done. Bean, turn around. Go sit over there. There, go get it. Go get it. There, come back. Now she's very confused. Bean, come. Okay, sit. I'm sorry if I'm making you woozy with my dog, my picture. There. Good girl. Very upset. She just didn't get a treat. Okay. because I know you wanted to see my dog. Yeah. Whoop, now I gotta get it straightened up. Okay, so here we go. We're crossing the charges. So chlorine's gonna go there, lead's gonna go there. Sorry, the negative one's gonna go there, 4 is gonna go there. But I don't write the ones, and I definitely don't write the negatives. So this becomes lead 4 chloride, just for fun. Lead 4. See, there's just not enough room. It gets all messy. I think, pretty sure y'all could just turn off the video, finish the rest of the line. In fact, you, excuse me, probably can finish the whole thing, except careful on this one. Okay, you get everything else right. That's amazing. So turn it off and see how it goes. All right. Here we go. The 2 goes there, the negative 1 goes there, but I don't write 1, so I don't care. Oh, sorry, I do care. BaCl2. Barium 2 chloride. Oh, hold on. If we look at the periodic table, notice barium down here. It's only one, what's the word? It only forms 1 ion. It's not like one of these guys. So actually that I don't need this part. I should have looked at my chart. I should know better. If you're not sure what to do, look on the chart. This will give you the names exactly the way you're supposed to do them. Positives will all come from here. The negatives will come on this side. So it's only these ones where you see the doubles where you need to pay attention and make sure you put the numbers in. Otherwise, you just don't. All right, this one's gonna look weird, but it's the same process. Boom, boom. So manganese, chloride, and 7. Ta-da! How'd that go? I hope that worked out well for you. We're gonna do exactly the same thing. Next line. So I'm gonna bring in first. Oops, now I made it look like an H. Right, plus 1, O minus 2. Remember, always, always, always the positive part first. Sorry. Oh, now my favorite pen's dying. Okay, that one's broken. 3rd time's the charm. So there, that seems more even. All right, crossing our charges. So notice on this one, our sodium, yeah, has something interesting happening. Na2. Oh, so we would say that's sodium oxide. This one is way more fun. So we get to use 2 numbers. Fe2O3. I want to go through that one just to make sure to prove to you without using these, and I guess we'll use those in a sec, why this works. So we have 2 Fe, and each one is a plus 3. That gives me a grand total of plus 6. I have 3 oxygens, and each one of those is a minus 2. That's going to give me minus 6, grand total of 0. Ta-da! It's going to balance. And because I just thought of them, we can also do, there's an iron. There's a plus 3. Now I need another plus, whoops, nope, do it right. See, if I do that, that's not electrically neutral. So when we're working with the paper patterns here, paper pieces, my little chippies, it has to form a square or rectangle. So that's not good enough. So we're clearly short some negatives, but you're not allowed. No, that would work. No, you're not allowed. You only have two choices. So there you go. More negative 2's because we're combining it with oxygen. And this is my iron, this is my oxygen. Oh, great. So I added that. Now I don't have enough positives. So the only thing I can add is another +3. Those are my choices. And somewhere, please let there be a -2. There. Now we're all happy. And this is all sticking together. It's electrically neutral because it's a rectangle. So Fe2O3. So you can use crossing the charges. You could play around doing this to make sure it adds up to 0, or you can use your paper pieces. Now, this one, I put a little star there on purpose. I'm actually going to tell you the cheat I figured out today. Actually, it's one of the students helped me with it. You know what? We're just going to cross the charges the way we normally do. But bear with me because we're going to change it a little bit. PB, whoopsies, goes that way. So 2 over there, 04. And then I want everybody to always look at these numbers and see if they have a greatest common factor or something you can divide out. And in this case, we actually do. It's PbO2 is what the correct answer is. I just want to make sure I say this right. Chemical formulas are the lowest whole number ratio that is electrically neutral. Or let me just build it, because this is one where it is easiest to explain. And I'm going to turn this upside down because I don't have a +4 piece. I didn't think I'd need them when I made these. Okay, so there we go. 1, 2, 3, 4. And we are using O2, so that's negatives. So 1 there. And another one. And it's done. It's electrically neutral. We're finished. If, oh, I'm gonna have to move my camera to do this. If we try and do PB2O4, you'll be able to see this. It's gonna work. Okay. So here's my first lead. Here's my second lead. And I can do this. But there's, hold on. There we go. See, it does make a molecule, but you know what? This is not connected to that part. We have now built 2 molecules, not just 1. So the moment we get our first rectangle, we are done. And I'm going to repeat one more time. This looks weird because I didn't have a +4 piece. I might just have to make some. Okay, ta-da. So there we go. So watch for that. It's not going to happen that often. It's when the 2 charges are multiples of one another. So I think if you just remember to just check if these 2, you can divide them down, go for it. All right, now B8 + 2, O - 2. Do you remember? We talked about the rule up here. If the numbers are exactly the same, you just bring them down. There's going to be no subscripts. And I want to show you why. Okay. There's my barium. And there's my oxygen. And boom, we're done. It's electrically neutral already. I don't have to build anymore. And just to reiterate what I said about the last one, if I try and do cross my charges and have 2 of these, and 2 of these, I got 2 molecules. They're not connected anymore. So done. And then this one, you know what? It's scary. No, it's not scary. We just cross our charges. So manganese 2, oxygen 7. So we would call this, just so I should name some of them, manganese 7 oxide. Ta-da! There we go. All right, on to nitride. How about, I would suggest, how do I put the thing back down? Just not. What was I going to say? Pause the camera, pause the video. I bet you can do this whole row all by yourself and get it completely right. Please pause. Oops. Apparently, I need to be done these videos pretty soon because I'm getting tired. I'm making mistakes here. But that's okay. We'll make mistakes. Okay, here we go. I bet you have them all right already. So, Na3, N, crossing the charges. Boop, boop. So this would be sodium nitride. How'd you do on this one? Done with the rule? I hope so. If there are matchy, F-E-N, done. You know what? I just thought of that rule we did today where we said if these numbers are the same, divide them out. So F-E-N. It works both ways. I'm quite pleased with that rule. It was Kyle that pointed it out or made me think of it. So there's a double check in case you forget that first rule. Oh, this is pretty. I'm going to cross the charges. We get to use lots of numbers. P, B, and it takes 3. And the N is going to take 4. I'm going to do this one more time. How come? So we have 3 leads, 3B, whoopsies, 3 PB at 4. So it's going to give me plus 12. And then I have nitrogen. I have 4 nitrogens at minus 3 each. It's going to give me minus 12. Net 0. So we're good. All right, crossing the charges. Here we go. Ba3, N2. And last one, manganese 3, nitride 7. It always feels weird when I'm writing a 7. It feels like it's too big a number. That's what I did to myself. All right. You know what? I'm going to stop this video and I'm going to make one more